This video discusses on how we can derive the quadratic formula, and that is another method in which the quadratic equations can be actually solved. But for the sake of interest, this video just aims at deriving the quadratic formula. The next, we're going to look at how we can make use of the quadratic formula to solve the quadratic equations. So take note of that. So we understand that the quadratic equation is given as should be ax squared plus bx plus c is equal to 0. This is what we call as the quadratic equation. Of course, the quadratic expression is given as ax squared plus bx and plus c. So this is the quadratic equation, and this is the quadratic expression. Of course, in this case, this is like the reference quadratic equation. This is the reference quadratic expression, in the sense that the variable can change. Instead of having the equation in form of x, you can have, let's say, am squared and plus bm plus c is equal to 0. So this particular equation, it is the equation of the variable m. And also in the same case, you can have it as am squared plus bm plus c. This expression, it is the quadratic expression of the variable m. So we can have whichever the variable, let's say, can be the actually quadratic equation with the variable r, q, w, y, s, q, or whatever you think about. So how should you have to derive the quadratic formula from the quadratic equation that we have? Now, first thing, ensure that the coefficient of x squared is 1. So to ensure that one, we'll have to divide everything by a. So in that case, we would like to have the coefficient of x squared to be as 1. So we have it as x squared and plus bx over a and plus c over a, which is equal to 0. So the principles that are being used are the same principle that we use when we're solving the quadratic equation using the completing square method. And from there, we should have to transfer this part to the other side. Now we have it as x squared and plus bx over a, and which is equal to negative c over a. Since this is the positive, as will be transferred to the other side, will be given as the negative. So we'll have that understand. Now, with respect to the general expression of the quadratic, you can see that this part is incomplete. The part which is lacking, it is the constant part, because we understand that the quadratic expression is given as ax squared plus bx plus c. So now for this case, upon transferring this part to the other side, now we have remained with that one, which is lacking the constant part. Hence, we should have to show that the constant part is missing. So therefore, we should have it as, we should have it as x squared, plus bx over a, and plus the part which is missing, it is a constant part, and which is equal to negative c over a, and the same constant part has to be introduced here. There's nothing to do with the transfer, but just have to introduce it here. And from there, we should have to solve the value of the constant, which is c. So how should you have to solve for the value of the constant, which is c? So the value of the constant is given as, using the formula, c is given as b over 2 and over to the power 2, of which this b is the coefficient of x. And what is the coefficient of x? Is given as b over a. Hence we have, b over a. We have it as b over a divided by this 2. That will be given as 2 over 1. And the over to the power 2, which is this 2. And then all this is the same as c. This is the same as having c being equal to, b over 2a. And over to the power 2. Of course, this is the same as having it as b squared over, we have it as 4a squared. Because in that case, we have it as b squared over 2a to the power 2, which is the same as b squared over, 4a squared. That's why we are at that point. Now we have the value of the c. Now how should you have it next? Now what you have to do is that we'll now just have to substitute where there is c, we'll have to substitute with that one. Therefore, we'll have it as x squared plus b over ax and plus b squared over 4a squared. But keep in mind that b squared over 4a squared, it is the same as b over 2a and over to the power 2. You need to keep this case. And now this is the same as having as negative c over a plus b squared over 4a squared. So we can have it as that. And from there we'll have it as, x squared. We'll have it as x squared, plus bx over a plus. Now we should have to express this, in form of this. Therefore, we'll have it as b over 2a and over to the power 2, which is equal to. Now we should add these two fractions. Let's try to add those. We have negative c over a plus b squared over 4a squared. The common denominator is given as 4a squared. Now 4a squared and 4a squared is given as 1. And 1 times b squared, we'll have it as b squared. And a into 4a squared is given as negative 4ac. And of course, having this case, this is the same as having it as b squared minus 4ac divided by 4a squared. Because if we have negative a plus b, this is the same as b minus a. Doesn't change anything there. So that is the same as that. So hence, we'll have it as, b squared minus 4ac divided by 4a squared at that point. So we can have it as that one. And from there, what we can have is, so now from this point, we just have to ignore the middle part. Now we'll have it as x squared plus b over 2a and over to the power 2 is equal to b squared minus 4ac divided by 4a squared. So as you can see, all the principles that are being used here, they are the principles that we use to solve the quadratic equation using the computing square method. And make sure you understand about the computing square method, because we're just using all the procedures we discussed about that one. Then since this is raised to the power 2 and over raised to the power 2, this is the same as having it as x plus b over 2a and over to the power 2, which is equal to b squared minus 4ac divided by 4a squared. Then we need to introduce square root both sides. So have to introduce square root both sides. And for this case, we'll have plus or minus this side. Therefore, we have x plus b over 2a, which is equal to. Now, keep in mind that if we have a square root of a over b, this is the same as the square root of a divided by the square root of b. It is the same as that. Now if that is the case, then what we'll have is this. What we'll have is that we'll have it as plus or minus the square of b squared minus 4ac divided by the square root of 4a squared. And from there what we'll have is this. From there we can have something like this. Now we'll have it as x plus b over 2a, which is equal to plus or minus the square of b squared minus 4ac divided by, and now what is the square of a? Actually 4a squared, this is the same as 2a. Now for that case we'll have to transfer this to the other side. We'll have x being equal to negative b divided by 2a plus or minus the square of b squared minus 4ac divided by 2a. And from there what we should have is what is the common denominator. We'll have it as 2a, and 2a into 2a, that is 1, and 1 times this, it is the same as plus or minus the square of b squared minus 4ac, and 2 into 2 is 1, and 1 times negative b is negative b, like that. So that is the x. Now therefore what we have, this is what we call as the quadratic equation that we can use to solve the quadratic. This is what we call as the quadratic formula that we can use to solve for the variable of the equation, and for instance x. And a, b, c, these are the constants from the given quadratic equation. And let's say if we can have, let's say, the equation which is given as 5m squared plus 6m minus 7 is equal to 0. It means the quadratic formula will be in form of m is equal to plus or minus, should be m is equal to negative b plus or minus the square of b squared minus 4ac divided by 2a. That is if we had used the quadratic formula. And likewise, if the equation it is an equation of r, we'll have r is equal to whatever. If the equation it is equation of q, we'll have q like that. And if the equation it is the equation of n, we'll have n. If the equation is of w, we'll have w is equal to whatever it can be. But it is not necessarily that the quadratic formula only has to be of x, because it depends on the variable of that particular equation. So that's how we actually derive the quadratic a formula from the quadratic equation. So next I'm going to look at how we can solve the quadratic equation using the quadratic formula. Thank you.